gonna get a fake tan, and that's what I'm doing to my hair. Oh my gosh. Okay, look at this dress. Guess how much money that was?
I definitely.
Too high?
Too low.
650? Higher? 1,000?
Oh, lower.
800.
Yep.
What? 800? Wow. Where's that at?
Here before.
That's hard.
I was a day bridal. I was gonna go to Macy's, but they didn't have the style I like. They had the back, they didn't have like the body suit. I don't know where. David Bridal has good dresses. Macy's has good dresses. Dillard's has good dresses.
Do you know if anybody's found my pencil box?
No one has come forth with a pencil box.
Wow.
And I only have that one class afterwards. It wasn't here then. So, yeah, I don't know what to tell you about
I
that.
just got it and I'm
Guess what? Today is a new lesson, new material for a lot of you. Oh yeah, and tomorrow, quiz. Just kidding.
It's Wednesday, Abby. Oh, I ordered myself a nice pair of shoes.
Me too.
Did I tell you? Oh, I ordered myself a pair of Birkenstocks.
Woo! Those are great for dancing in.
They're camo.
They're great for dancing in.
No,
You're right, they're not.
Look. Hold on, let me get the picture.
Today, we start our journey into freak out trigonometry. Trigonometry.
So when I say last night I went to Ritter's to get ice cream, instead of saying M&M's, I say M&M. So now my friend makes fun of me. She starts laughing.
Okay. Woo! So, what we're going to do today, this packet's going to take us to the period you fill out. And this is like the building blocks for where we're going to be, what we're going to be needing to be able to use for the next 3, 4, 5 weeks easily. Okay? So, it's all about angles. And you guys have dealt with angles, of course, in geometry. Before we go ahead and go any further, Yusef wants in. Yeah, okay. And let's see. This, close that mumbo jumbo. This, there. Working with angles. So, when you hear the word angle, what do you think? What do you see? What do you know? What could you tell me? What could you tell somebody else? What are the different things that come to mind when you think about angles? There's a lot of things that come into my head. Yeah. Degrees. Okay. One of those things might be degrees. Okay. And that's how you do what? What's the idea of degrees? That's how you measure. It's a measurement, right, for an angle. Okay, great. What else comes to mind? Yeah.
Like the obtuse, acute, and
obtuse and acute. Yep. Classifying them by their size. Obtuse, acute, right. We'll put all those. What else? What other things come to mind? Like, what is an angle?
When I hear angles, I kind of think of like people taking pictures, like when they do it from like a higher angle.
Oh. Okay, that's an angle, okay. So, but in geometry, what was an angle? I don't know. Come on, what's an angle? You can all draw an angle, right?
Yeah.
Is this an angle? Here, I'll use different color. Is this an angle?
No.
No.
Wait, what is it? Two lines that like intersect with one? Like,
That is not an angle.
The measure?
Is this an angle?
No.
It's a bunch of angles.
It's
All it has angles in it, but it's not an angle. It's not a singular angle, you're telling me. It's not, okay? Is this an angle?
Yes.
Yes.
So what is it?
A right angle.
Well, kind of looks like it is, but in what was your definition of an angle? It was what? Two rays with a common end point. There's two rays at a common end point, but in the rotation between them was an angle. Okay? And so yeah, that if you were asked to just draw an angle, they said draw an acute angle, you guys would have done this. Hopefully, something like that. If you had a quiz that said draw an obtuse angle, you guys would have done something like this. So you know what an angle is, and you know the idea that it's two rays. And where those rays are at is called the, yeah, but on the angle it's called the vertex. The vertex, right? Okay. You guys know a lot about angles. I know you do. Okay? And like it's, if I was facing this direction and then I rotated like this, that's the measure of it, right? It's the rotation to go from here to here. And that's that idea of degrees, right? And let me ask you this. If I was facing this way and rotated here, and then I stopped and then I rotated here, did I rotate the same amount both times? If I started here like this and went boop and rotated, and then I went boop and rotated back, did I rotate the same amount both times? Is the question. That's all I'm asking you. You're saying no, I didn't. It's okay if you want to say that. You might be right. Who knows? Because I'm not going to answer the question myself right now. You guys will find out the answer to that in a little bit. Because right now I'm not going to answer it. But a lot of you said yes. Abby said, I like Abby. Abby's great because Abby tells me what she thinks. I love that. Okay, here we go. Well, we're going to move on. And some of this will be familiar. Some of this will not be familiar. And that's okay. So here's what you have in front of you. So at the top of this, these are some terms that you should be familiar with. Now, not necessarily now, but trigonometry, central angle of a circle, complementary angles, supplementary angles, degree, and radian. My guess is, of those, everyone in here probably feels pretty good about 3 of those for sure. Be my guess. I would say most of you feel pretty confident with these 3 ideas right here. How many of you would say that that's probably pretty true? Yeah, okay. And trigonometry, I mean, you might not know what the actual definition of it is, but you have an idea of what trigonometry was maybe. What about this one though? This one I have to find out about this one because if you don't know this, we have to talk about it. Does anybody know what central angle of a circle is?
It sounds familiar. Yeah.
What, Savannah, are you saying something? Okay.
Yeah, like a radius or something.
So, and this is what, oops, hit the wrong one. This is one of these things that I'm not quite sure what got accomplished last year because of COVID and what got dropped. Okay?
Yeah.
So, when you're dealing with circles, and you don't have to write this down, I'm just putting this up here. So, if you're dealing with circles, okay, and I draw angles in a circle. I could draw an angle that looks like this in a circle. Did you guys see those last year?
Yeah.
Yeah. Is that angle considered a central angle? No, it's not a central angle.
Center.
Yeah.
If it's from the middle, then the measure of that angle is the measure of the...
Yes. Yes. Okay, so here we go. A central angle is when the vertex is at the center of a circle, and the sides are both a radius of the circle. And as Rachel was just saying, the measure of this angle in degrees is the measure of this arc in degrees. They have the same measurement in degrees.
Yeah.
So that's something how many of you did see that last year? Most of you did. Rain, did you see that last year? Okay, hold on. I'm gonna see them around here real fast. Man,
Bless you.
I knew it was coming. I could just feel it. All right. So yeah, so that's great. Understanding that this and this were the same. What do we call this region between? What do we call this part right here? It's an arc. And if it's between the two sides, it's called the intercepted arc. Does that sound familiar to you at all?
Yes.
Okay. So, because that terminology, I might use it, so I have to make sure you understand it before I start throwing those words out here. Okay? So we've got a central angle here. We've got, this is called an intercepted arc. We all know that that's a radius. That should not be a problem. This has a measure in degrees, and it also has a length. Did you guys do arc length last year? Yes? Yes? Okay, good. All right. By the way, what's this angle here called? What kind is that?
Not a century.
It is a cube, but in the circle, what's it called? What's that? Inscribed.
Good job, Mom.
And whereas this was equal to this in degrees, this is half of this. Now, you don't have to know that for this class, but that was in geometry. Inscribed angle is half the intercepted arc. Okay? Okay. So now if we go back, we actually know what this one is as well. You just needed a little refresher on what a central angle of a circle is. So we actually know a lot more here than we thought about. Really, the two that you don't have really good ideas about maybe are what is a good definition for trigonometry and radians. This is the biggest thing today that's new that you're going to have to know. So when we get to that, it's going to be very, very, very important. It's not going to be review, it's going to be new. There's some other stuff that's new along the way. So let's go ahead and do this. So we can fill out a few of these. We'll come back and do this one later. This one, we can just say what? Angle with its vertex at the center of a circle and its sides are radii. Well, they're what? Radii, right? So central angle of a circle, we're just going to say angle with vertex at the center and sides, which are radii. Okay, easy enough? Yeah, because it's radii, it's plural. Okay, great. Woo-wah! Now complementary, we didn't talk about it, but you guys I think do know that one, right? What's complementary?
They add up to 90 degrees.
Yep, two angles are the sum of 90. And then a supplementary was
Angles with the sum of 180.
two angles with a sum of 180. Okay. If you had to describe what a degree is, kind of a hard thing to talk about. I mean, we know it's a unit of measurement. And it's a unit of measurement which talks about what? Rotation. So a degree is nothing more than a fraction of a full rotation. We say a full rotation is what?
180.
Full rotation,
360.
360 degrees, right? So a degree is just, and I'm not going to write a definition for this, but it's how you measure rotations based upon what fraction of 360 degrees you have traveled. They made it so that 360 degrees is a full rotation, okay? So I'm not going to write down a formal definition for that. That's not a big deal. You guys understand how to measure that, and most of you could probably give me an estimate for angles as far as like what they were in degrees if I asked you to. If I simply said to you, estimate, what do you think this angle right here is in degrees? I would hope everybody in here would tell me it's greater than 90, right? So you might say it's about what? 110, 100, 105. You would give, would you say it's 170?
No.
No, that would be a bad estimate, right? But if you understand degrees, you would have an estimate of about maybe like anywhere from 100, right around 100 somewhere, plus or minus, okay? Not a big deal. You understand that. That's great. You're comfortable with that idea. hopefully, soon, you'll be comfortable with this like you are with this. Now, we're going to go ahead and move down and start filling in some of these bottom things. Here we go. First thing is, you notice I've given you a picture here. Now, that picture is not like you're looking through a scope on a rifle. Okay? There's not going to be like you're not supposed to draw a little deer in there or something. That's not the idea. Okay? This is the x-axis, the y-axis, which means that is the origin. We're going to be looking at circles that are centered at the origin. That's going to be our primary spot right now we're going to be working at. Okay? We're looking at circles that are centered at the origin. So again, this is the x-axis over here. This is the y-axis. This is the origin, right? We also know that these are called what? Quadrants. This is quadrant 1. And then, of course, this is quadrant 3 and 4. Okay? So those are things that you should kind of remember from not geometry, but from algebra. The ideas of the quadrants. All right? So, anything else that I want to talk about? No, I think that's good enough for right now. So here we go. The first thing on here, an angle. An angle is determined by. So, well, an angle is determined by. We're going to talk about that and say something a little different than geometry. In geometry, we said it was two rays that had a common endpoint. In here, an angle is determined by rotating a ray about its endpoint. Okay? Rotating a ray about its endpoint. That's what we're going to kind of think of it as. It's a rotation. It's all about rotation. Okay? So an angle is determined by rotating a ray about its endpoint. Notice there's two sides to an angle. There's an initial side and a terminal side. So I'm going to go ahead and draw an angle. When I draw an angle, I need a ray to start with. That's easy enough. I'm going to draw my ray right here. Here's where I'm going to start my angle at. So this would be considered the initial side. Okay? So the initial side of an angle is the position the ray starts at. We all know that ampersand means at, so I just wrote an ampersand instead. Okay? Boom. What you need, bud?
I like my Chromebook here.
Oh, yours is the one charging?
Yeah.
That's right. I couldn't remember who was it that borrowed one, so. Okay, so the initial side, this is the initial side. Now I need to go ahead and I would rotate it. Okay? Now I have a choice. I'm going to rotate this. So I'm going to go ahead and say, let's say I was facing this way and I rotated and I went, and I stopped right here. Then I get this. Where I stop at is the terminal side. Okay? So the terminal side of an angle is the position the ray stops at. So we have an initial side and a terminal side. Now, in order for me to know which is which, I really should draw a little arc on the inside with an arrow showing the direction of the rotation. So if I did this, this is telling me, oh, it started here and it rotated to this direction here. If I had it going the other way, this would be the initial side and this would be the terminal side. So this arrow in here is telling me the direction of it. Okay? Hopefully that's simple enough. So there you go. There's an angle. Easy enough, right? We got this. We're feeling good about ourselves. We know the vertex of an angle is what? Well, the way we're talking about it, it's the point that the ray rotates about. But it's also what? The point where the initial side and the terminal side meet. So I'm just going to put that here. I'm just going to say point where initial, I'm going to put IS for that. Capital I, period S. And terminal side meet. Okay. Are we okay so far? This is just like real small things. Now, this idea though of initial and terminal side, those are important. That terminology, especially terminal side, is hugely important. This one right here, you need to understand terminal side. Okay. Then all of a sudden we get this thing that says an angle is in standard position. What? What does that mean? Okay, so here we go. So when I ask you guys all to draw an angle, we're going to have a standard way of doing it. And we're going to draw it in standard position. So we have to know what that means. Standard position means initial side is on the positive x-axis. So the angle I have drawn right now is not, I repeat, this is not in standard position. If I want to draw an angle in standard position, its initial side has to be on the positive x-axis. Now any angle I draw, any rotation now would be in standard position. So maybe I go ahead and I rotate like this, and I stop here, and this is the terminal side. This blue angle, I'm going to call this beta. Beta is in standard position. Okay? Right? This one's not. So we understand that there's a standard position that we can all draw it from. So if I said, hey, I want you to draw an angle in standard position that has a measurement of, you could do it. We all know it's going to start at the exact same spot. Are we getting nervous about this material yet? No. Good, we shouldn't be. We should not be getting nervous about this. Not yet, at least. All right, here we go. A positive angle. Whoa, 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 whoa! Look at it saying there's positive angles and negative angles?
Wait a whole minute.
Now, I know in geometry, because I taught it for 19 years, there was no such thing as a positive angle and a negative angle. There was no such thing at all. Well, now there will be. Okay? Now there is. So here we go. A positive angle is generated by a, now this is a word I hope most of you will know this word. By a counterclockwise. Before I go any further, of course, this terminology exists because of this type of clock. Because on this type of clock, we know that the minute hand, the hour hand, the second hand all sweep this direction. So that's considered clockwise. If you go the opposite of that, that is considered counterclockwise. So that means if I'm looking at this picture and I'm going to start my angles here, that's telling me then if I rotate this direction, this will be a positive angle. If I start here and rotate this direction, and this is counterclockwise, that will be a positive rotation. Now, if that's a positive rotation, guess what a negative rotation is going to be? Going in a clockwise direction. Exactly. So this one now, whereas a negative angle is generated by a clockwise rotation. So again, on this picture up here, if I start here and go this direction, this is a negative rotation. So now we have both positive and negative angles. That's different. That's a new concept for us. That is a new concept. So in other words, this red angle is what type of an angle? Positive. The blue one is a negative angle. Okay? so got that? Last thing we're going to do here. Okay? It says if two angles are co-terminal, then they have. Okay, so terminal. We've had the word terminal here. Terminal is where an angle stops. The prefix co, with, coexist, with, right? So these are two angles with the same terminal side. But not only the same terminal side, they have to have the same initial side. Whoa, 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 whoa. Hey, wait a minute, whoa, 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 whoa. Wait, whoa, whoa. Wait a minute, whoa. What just happened? I just wanted to do a blank page. Okay, here we go. So again. Woo! Here we go. I got this. I got this. All right. This angle right here. Okay? There's angle theta. Theta is this angle. What kind of an angle is that? Positive. Great. This angle right here, this is beta. It's negative. They have the exact same initial side and the exact same terminal side. Those two angles are co-terminal. So on this picture right here, beta and beta are co-terminal. All right, guess what? I'm going to draw another angle that's co-terminal with theta. Are you ready? Here it is. Is this green angle starting and stopping at the same place?
Yes.
Yep, it sure is. This is alpha. Alpha and theta are also co-terminal.
Whoa, gee.
Let's do another one. Here we go. I'm going to do this one. And, oh, let's use a highlighter. Let's use green. Here we go. Is that starting and stopping at the exact same sides?
Yes.
Yes, it is. This one right here, let's just call this one phi. It is co-terminal with theta. As a matter of fact, it's not just co-terminal with theta, it's co-terminal with beta, it's co-terminal with alpha. All of these angles are co-terminal. How many co-terminal angles are there for a given angle? An infinite number. Because every single time I go around another full rotation, I have created a new co-terminal angle. Okay? So, the definition of co-terminal angles, if two angles are co-terminal, they have what? Same initial IS and TS. And that stands for initial side and terminal side. Okay? That's what it means for two angles to be co-terminal. Co-terminal. Okay, where are we at here? 4th, 5th. Oh, we're doing great on time. Oh. All right. Before we go any further into the notes, is there anything on here at this point in time you want to ask about? Like you want to go further with, you're like curious about something, or you want clarification on? Either one of those, any of those. Nope, okay. All righty. Wow! 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 All right, here we go. This next section is the easy one, because you all can fill this out without me even telling you, the top part at least, where it says degrees. I believe everyone in here could fill these two blanks in without me helping you at all. I'd like everybody to try that. And then I'm going to put the answers up there. You've got 15 seconds. No, you do not. You just don't get kicked out of the classroom if you get them right.
You know, I think my dad tried to teach me gradients like last year in the car.
Yeah, he did. He told me about that.
And I feel like I got like 25% of it.
Hey, there you go. We'll fill in the rest of it. All right. So a full revolution counterclockwise, which means it is a positive angle, around a circle corresponds to blank degrees. Yeah, 360 degrees. Of course, if that was a clockwise rotation, it would be negative 360. A half revolution around a circle corresponds to 180. That is stuff that you guys already know. And you don't just know those, you actually know this. If I'm going from initial, this would be what, how many degrees would I be if I start here and stop here? I don't even move. 0, right? If I start and I never move, I'm at 0. This would be at,
90.
yeah, you guys know that. This would be 180. This would be 270. And of course, if I get back to this, I'm back to, so 0 and 360 are co-terminal angles, right? Because they both have the exact same initial and terminal sides. All right, woo! Here we go. Radian measure. So this is now the other way we measure rotation/angles. Before we do this, I'm going to give you a problem to try, because you said you guys did this last year in geometry, so we're going to do one. I don't know if I have a picture here. I do. There it is. Now, don't worry about this. These are just concentric circles. They're just two circles that have the exact same, what? Center. That's concentric circles. They have the same center. Okay? I'm going to tell you that this, I'm going to look at this circle right here, this inside one, okay? I'm going to tell you that this length right here is 2. Is that okay so far? I haven't lost you.
Yeah.
I'm going to draw an angle in standard position right here. And I'm going to tell you that this angle right here is 82 degrees. So far, so good?
Yeah.
And now all I'm going to do is I'm going to ask you to find S, and S is the arc length. So if you would just do that, if you don't remember, I want everyone to think about it for a second. That's all we're going to do. Think and see if you can remember how to do that.
What did you say this
Huh? I mean, I could have given you an easier one, I guess, to start with, right? Like, here we go. What if I did this? What if this was on the ground? I'm just going to put, you guys, I'll take care of you guys in a second, I promise. Let's say this is on the ground, it's a mat, and I put an ant here. And I trained my ant to run around this circle. And I'm actually going to have it run from here to here. Now you guys could, I hope, find out the distance my ant runs. If I asked you to find the distance of this arc, I'm really asking you to find the what? The circumference. Now, how do we find circumference of a circle? What's the formula? It's either pi times diameter or 2 pi r, because 2r is diameter. It's either way you think of it. I'm going to put 2 pi r. There's a reason for that. Okay? Boom. So if my ant would go all the way around the green path, I would just replace r with what? 2. So 1 lap for my ant would be 2 pi times 2, which is 4 pi. And then I don't know if it's inches, feet, it doesn't matter what it is, right? It's just 4 pi units. That's how far they would run. We're okay with that, right? Now, I'm telling you, my ant couldn't do that because my ant started running. My ant was running, and they were running, and right when they got here, they broke a leg. And they fell. And they couldn't go any further. I want to know how far they ran. That's what I'm asking you. It's a what? It's a fraction of the circumference. Now, how do I know what fraction of the circumference it is? It's 82 out of 360. So if I want to find S, this value of S, it would be 82 over 360 times 4 pi, which is the what? Circumference. Okay, here we go. I'm going to start doing this in my head. 4 goes in itself once, goes into 360 90 times. So now I've got 82 pi over 90. And now, I want exact. I'll give you that decimal 2. And now I can divide both of those by 2 for sure, which would give me what? 41 pi over That's how far they ran. They ran 41 pi over 45 units, whatever it was. Okay?
One fast thing.
Is that okay?
That would be.
Okay. So, we're okay with that, right? That's how you find arc length. Arc length is nothing more than arc measure, which is in degrees, over 360 times 2 pi r. That's how you find arc length. It's nothing more than a fraction of the circumference. Okay? All right. Must be some reason. Here we go. All right. The measure of an angle. Here we go. We're talking about radians. It is the measure of an angle, and it is determined by. No, listen up. It is determined by the intercepted arc's length compared to the radius. Okay? It is determined by the intercepted arc's length compared to the radius. All right, now, what does that really mean? What am I saying here? Oh, here we go. Let's go one step further with this idea of 1 radian. Let me explain to you what 1 radian is. Here we go. I'm going to get a new page. Whoop. There it is. Beautiful circle. Okay? I'm going to have my angle here in standard position. Okay, so you ready?
Yes.
Here's R. I'm going to start rotating. I'm going to stop right about there. Guess what this length is here? When the arc length is equal to the radius, this is referred to as 1 radian. Again, when the arc length is equal to the radius, you have gone 1 radian. That is not a length, that is a rotation. You have rotated 1 radian. You're going, oh, that still doesn't make any sense, Mr. Strider. How's that? Well, I don't get it.
It's not like fixed. It depends, right?
Well, that's a good question. Does it depend? Well, I'm going to go over here again real fast. You guys are kind of just flipping around because you don't have all the stuff I'm doing up here because there was too many pages. I want to look at this real fast. If this is 82 degrees on this circle here, if I were to extend these out like this, would this arc also have a degree measure of 82 degrees? It would have to. It would have to. Can't be different. This would also be 82 degrees. Well, guess what? If this measurement in degrees is equal to this measurement in degrees, then this measurement in radians better be equal to this measurement in radians. All right, so guess what? Here's how this is going to work out. This is where it becomes a lot easier if I just give you one little piece of information, and it's going to be, here we go. So I already did this. I wrote it down. 1 radian is the measure of a central angle theta that what? Has an intercepted arc equal in length to the what? The radius. Okay? Now, algebraically, this means that theta equals. Okay, here's where it becomes a lot more simple. Okay? Algebraically, this means that theta, the angle, is equal to the arc length. S is the arc length. Okay? S is arc length. It's the arc length divided by the radius. Because I said, if they're the same, 1 divided by 1 is 1, or 5 divided by 5 is 1. So when I take the arc length divided by the radius, I get a rotation which is called radians. Now wait a second. Hold it. Okay, look. Let me think about this for a second. Let me think about this. Get this stuff out of get out of there. Why are you up there? Okay, here we go. Here I am, I start here. When I start here, I'm at 0 radians because I haven't moved. 0 is 0. I don't care what unit you're in, it doesn't matter. And I'm going to rotate. 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 And I'm going to stop right here. Okay? Now, can anybody tell me? Now, so this is my angle theta. This is theta. There it is. And I want to calculate theta in radians. I said it's the arc length, S, divided by the radius. What is the arc length of my red arc? What is this length from here to here? What is S? What is this distance? The distance around a circle is called the circumference. What's the circumference, in other words? That's degrees. What's the circumference? 2 pi r. Okay? Are you okay with that? This S is 2 pi r. When I go around a rotation, the distance I travel is always going to be 2 pi r. Divide that by r, and what do you get? A full rotation is 2 pi radians. That's going to be the key to this. Okay, take your break. When you come back, we'll keep going. We'll keep working on this.
I'm so
I might fall asleep. So I don't know what he just said. What does it say? R equals K?
R equals 1 E. I don't know. I'm done with this unit already. I'm started.
You're here! She said, you're here.
So that means that if it only went across 1/4 of the arc, it's still 2 pi r for S.
I'm gonna be honest, I was falling asleep, so I have no idea.
Well, something going for the circle. It would be
Divide 360 by 360, which is 1. So it's 1 times 2 pi r. It's just 2 pi r. That's why it's 2 pi r.
What?
That's why it's just 2 pi r.
Because
It's
the
not a fraction
formula
of the
for arc
circumference.
length. So arc length is x, right? Yeah. So the formula for arc length is the arc measure over 360. And the arc measure is 360, so that would be 360 divided by 360, which is 1.
Mhm.
And then at the other part of the formula is after that times 2 pi r, so then it would just be 1 times 2 pi r, so then it's just 2 pi r. So that's why the arc length is 2 pi r.
Okay.
In this case, the arc length is the entire circumference.
Yeah.
So there's,
So why didn't you just put 2 pi r? Because it's 2 pi?
because the circumference is 2 pi. That's how you solve for circumference.
I don't think I need to be in this class anymore. I think I need to go down to like Algebra 1. It hurts my brain. I don't. Oh, R.I.P.
I need more sleep.
This is very interesting. I'm remembering, and this is also blowing my mind. Like, what? That would technically mean, no matter what the size of the circle is, a certain degree would be just 180.
I want some pasta. Let's do this. Abby, my dress is ready to get picked up today. Oh my goodness!
I thought you were about to say ow ow, and I'm like, what?
No, it wasn't supposed to come in until the 14th of
Yeah,
April.
we all go the same way. Wait there. You should totally just come to school one day with it on and just be like, yeah, this is what I'm gonna look at.
And I don't have to have my own school. So I can go straight from school.
You're getting close to late 2 o'clock. Even if he's out there.
Oh my God, not a unit circle. Let's see how it is. Unless I do it. You can't cheat. There's like a way to remember. But I've seen it. Look at that all the way.
All right. We're back. Woo-hoo! All right. So what we just found out here, when I did this, when I did a full rotation, I traveled a distance of 2 pi r. And if I take that arc length of 2 pi r and divide it by the radius, I have ended up rotating 2 pi radians. So a full rotation is 2 pi radians. So right here, a central angle of 1 full revolution counterclockwise corresponds to an arc length of, now this is arc length of S equals what? 2 pi r. Then we can say that the radian measure of 1 full rotation is 2 pi radians. 2 pi radians. Okay, so I'm going to draw it right here. Boom. Here's my circle. I'm starting right here. That is at 0. We know if we go all the way around back to here again, we will have gone 2 pi radians. Look what it says. A half revolution. That means going from here to here is what? Pi radians. It's half of 2 pi. And then it says a half revolution, so that's right here, is pi radians. Then it says, similarly, 1/4 of a revolution. That means from here to here. It's pi over 2. It would be this distance in 2 pieces, divided by 2. Okay, so now, yeah, the next one. And 1/6 of a revolution, 1/6 of it, which would be in this area right here, would be what? Now, look, what we're going to do every time is take arc length divided by r. What's the arc length going to be? I have to fit, in order to find what theta is, think about what 1/6 of 2 pi is, guys. What's it going to be?
1/3.
Not in degrees, in radians though. You're in degrees.
Pi over 3.
Pi over 3. All I do is take 2 pi divided by 6, which is pi over 3. Look what each one of these was. 2 pi. This is what? 2 pi divided by 2. This is 2 pi divided by 4. This is 2 pi divided by 6. If I wanted to know 1/8 of a rotation, it's not there, but what would 1/8 of a rotation be in radians then? What's that? Pi over 4. It'd be pi over 4 radians. I'm going to put RAD for radians so I know what that is. Okay, hold it. Let's make sure we understand what radians are now. So you have a circle centered here. You've got a radius. You start rotating. When you've rotated and you have cut off an arc length of r, this would be 1 radian. Okay? When this and this are the same, you would have 1 radian. So what if I did this thing? I have this, I start here. I'm going to rotate, 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 rotate. I'm going to stop right about here, let's say. Okay? I'm going to tell you that this arc length S, oh, let's see here. What do I want it to be? It's 12. It's 12. Okay? And I'm going to tell you that the radius is 5. And I want to know what the measure of beta is in radians. All I would do is take what? 12. It's always the arc length divided by what? The radius. Boom. It'd be 12/5 radians. Or if I wanted to write it as a decimal, 2.4 radians. What does that mean? That means that I have traveled 2.4 radiuses around the circle. Radians, radius. How many radii have you traveled around the circle is what a radian is. That's all it is. How many radii around the circle have you traveled is what radians is. That's why the words are so close to each other in how you say them. Radians, radius, radii. Okay? So again, it's the number of radii you've traveled around the circle. That's what radians is. But it's not a length, it's a rotation. It's a rotation. Okay? And you'll get better with this as we keep going more and more and more into it. Promise you, you will. The first day, I don't expect you to be experts on radians. Bottom part now, here we go. Look what we got. These terms are not going to change because we're in radians. Angles with measures between 0 and pi over 2. Here and here. What kind of angles are those going to be? Think about if I drew an angle in here like this. This is my angle right here.
Oh, cute.
What?
A cute.
It's acute, exactly. Those terms don't change. It used to be acute was between 0 and 90, but if it's between 0 and pi over 2 radians, isn't that saying the same thing? We're just in a different unit of measurement, that's all. And then between pi over 2 and pi, if it ends up being here, what kind of an angle will it be? Obtuse. Okay? Okay. And we kind of covered this already. How did I get new coterminal angles when I had an angle to start with? What did I do? You remember what I did back here? What did I keep doing? I did what? Added more rotations, right? I could either add it, but if I went this way, I wasn't adding it, I was subtracting because it's a negative angle, right? So in order to get coterminal angles, right here, okay, add, really? What was that nonsense about? Add or subtract multiples of 2 pi. Why do I say that? Because 2 pi is what? 1 revolution. This bottom part's all about radians. Okay? It's all about radians. All right. So here's what we're going to do. We're going to practice a little finding angles in radians. You okay with that? We're going to do one problem here. One. That's it. Okay? Woo. Show up. Show up. It's going to start right here, of course. And it's going to end right there. And it's going to rotate this direction. Oh, I'll be nice. I'm going to go the other direction. We're going to go this direction. And I'm going to tell you what this is in degrees. Okay? This is 210 degrees. And I'm also going to tell you that this radius right here is 8. Okay? What I'd like you to do is I would like you to tell me, what would this be in radians? Now, all you have to do is what? What do you have to do first? If this is equal to S over R, do you know R? It's 8. Do you know S yet? No. Can you find it though?
Yeah.
Yes. So would you do that real fast?
Yeah.
Go ahead. Do it. So S, I'm going to draw what S is. S is this thing right here. Here's S. Because remember, S is not the entire circumference. It's just the what? Arc length. It's the length of the arc between the initial and terminal side. Who's going to help me find? I told you how to find S. How do I find this? Whoa, whoa, whoa. 210
divided by 3.
over 360. This is arc length. We did this earlier on. Remember the formula I gave? Hold on.
Yeah.
That's what we're doing here. Okay? Because this is how we need the arc length in order to find the radians. Right? So arc 210 over 360 times, which is going to be what in terms of pi? 16 pi. Now, we're going to simplify this all out. Okay, now I can do some of this right away. I can simplify. Like, since they're both ending in 0, you can get both rid of the zeros and divide both by 100, right? Or 10 here in this one. So I've got 21 times 16 pi over 36. You guys hopefully can simplify that some before I keep going. Because 21 is 3 times 7 times 16 times pi over 36 is 3 times 12. Oh, so the 3's are going to do what? Cancel out. Hey, 16 and 12 have a common factor of 4. This is going to be a 4, and that's going to be a 3. So now I've got what? 28 pi over 3. Okay, now what does that represent, that number? That is the arc length. Thank you, Lena. That's the arc length. Okay, that's the arc length. All right, now, in order to find theta now, its arc length, 28 pi over 3, divided by the what? Radius, which is 8. Ooh, gross. How in the world do you deal with that nonsense? You could use Desmos, I guess. Just don't let it multiply that pi out and give you some decimal goo-goo. Thank you. So this is 28 pi over 3 times 1/8. Dividing by 8 is the same as multiplying by an 8. Oh, okay. So now what do I get? I'm going to kind of scoot down here. I'm running out of room. I get 28 pi over 24. Both of those can be divided by
2.
They could be by 2, also by 4, right? If I go by 4, it's what? 7 pi over 6. This angle right here is 7 pi over 6 radians. Okay. Whew. That was an awful lot of work, wasn't it, Hamza? Just to convert from 210 degrees to radians, wouldn't you think it'd be a lot easier than just doing that?
Yeah.
I hope. I hope it is. That's an awful lot of work. I have to go ahead and find an arc length and plug that back in, and too much going on there.
I'm gonna say this right now. You know it, and you're gonna tell us.
Well, of course I am, because look on the next page. It says on the next page, to convert from degrees to radians or radians to degrees is the conversion.
Yeah, I saw the units.
Right.
I've seen TikToks of it.
Here we go.
It's bad.
I got so scared when I saw it.
This right here, guys. Okay, here we go. So, to convert from degrees to radians or radians to degrees, if you know the following, that 2 pi radians is equivalent to 360 degrees. We all understand that, right? If I divide these both by 2, then that would mean that pi radians is equivalent to 180 degrees. This is the key to this conversion right here. There's, because I have pi radians is 180 degrees. So I'm going to show you how you convert these. It's very, very simple. I've got degrees at this end, and I've got radians at this end. First thing I want to do is I want to go from degrees to radians. I want to go from here to here. If I want to do that, I simply take degrees and I multiply it by pi over 180. That's all I have to do. In other words, if I would go back to the problem we just did, what was my angle? 210. Here we go. 210 times pi over 180. That's 210 pi over 180. Those are both divisible by 10. Both divisible by 3. 7 pi over 6.
Just do all that from now.
Yeah. Why? Because you want to know this. Right? Wouldn't you rather know how to do it this way?
Yes.
Yeah. Okay?
Because you need to know how it works.
This is all about how it works. Exactly.
That's
See?
why I wanted math. You know, all this dumb
Okay.
math, you know how it works.
So, here we go.
True.
Now look, that's how you go from degrees to radians. If I want to go the opposite direction, we call that the inverse direction, right? I multiply by the inverse of this. So if I want to go this direction, I multiply by 180 over pi. Okay? Well, I have inverses. All right. Okay. So a rotation of 1 radian is when an arc length is what? Equal to the radius. So if I have a circle with a radius of 12, what does my arc length have to be in order to go 1 radian? 12. If I were to go 24, I would have gone 2 radians. Okay? All I have to do is take arc length divided by radius. Okay? If I'm converting, it's plain and simple. Okay, conversions are right here. Okay? Okay, now, bottom part. This is going to be huge for you guys. And now you're going to see why I did something with you before spring break and yesterday as well. So what we're going to talk about right now is called the unit circle. Okay, the unit circle. Now, it is referred to as the unit circle because it has a radius of 1 unit. So instead of calling it the radius of 1 unit, so the radius of 1 circle, we call it the unit circle. Again, it's called the unit circle. Why? Because R is equal to 1 unit. It could be 1 foot, 1 mile, it doesn't matter what it is. It's got a radius of 1. All right? Now, here's what I want you to do real fast. I would like you to look at this, and I would like for you to tell me any of the marks on here and its measurement in degrees. Now we want to be in standard position, which means we know we want to start right here. So I'm going to go ahead, I'm going to highlight that. That's where I'm going to start at. Let's highlight that in this pink color. Okay. So that's going to be my initial side. if that's the initial side, you can tell me this measurement right here in degrees. It's what? 0, because that's where you start at. Boom, 0. All right. Can you give me any other places on here you know for sure? Yep.
The top one's 90.
Top one's 90. Yep. Left one's 180. Bottom one's 270. Any more? And what? 360 when I get back here. Boom. You got those. Easy enough. Okay? That should be good. Now, guess what? I'm going to tell you, now these angles on here are known as the familiar angles. These are the ones you have to be familiar with. You have to know them really and truly like the alphabet. Familiar with them. Here we go. I'm going to write down what these are in degrees. This very first one here is 30 degrees. The one right above it's 45.
Whoa.
And this one's 60. Now let's just stop for a second. Remember before break and yesterday I talked about what? Special right triangles. And what were the angles involved? 30, 60, 90s and 45, 45, 90s. Familiar angles are those types of angles. Okay, here we go. We're going to keep going. This is at 120. This is at 135. Thank you very much. This is at 150, and of course we're at 180. Now, and of course, I'm going in a positive rotation on this. If I went the other way, they'd be negative, but we're just doing a positive one. What would this one be right here? 210. 225. 240. 270. 300. 315. 3.
Oh no.
What'd you say?
3. Wait.
You said 340. I don't think you meant that.
I said 330. I meant to say 330.
You meant to say 330. Okay, I like that better. There we go. Great. There they are. They're in degrees. All right. Now, we did that because now we understand, hopefully, that why I maybe was talking about special right triangles, because those are those angles. And this really, by the way, 150 is nothing more than a multiple of 30. 135 is a multiple of 45. 120 is a multiple of 60. 210 is a multiple of 30. 225 is a multiple of 45. 240 is a multiple of 30, as well as 60, right? All of these deal, though, with the 30, the 45s, and the 60s somehow. They're related. Okay? All right. Now, let's do these in radians. That's why I have those little marks on the side over here. That's where we're going to put radians, because that's what you're really going to have to become really good at understanding. We need to know the familiar angles in radians. So we're going to go around this. So we know if it was 0 degrees to start, it's going to be 0 radians. Now, we know 360 is how many radians? 2 pi. Okay? So let's fill in the ones we know. We know this is at 0. We know this is at, what was it in radians of? Pi over 2. This was at pi. The bottom one down here is at? Think about it, guys. 1 pi over 2. 2 pi over 2. 3 pi over 2. And 4 pi over 2 is what? 2 pi. Okay. Are you ready? Now, let's think about this. 30 is what fraction of 360?
1, 9. No. 1.
What's that? It's 1/12. If this is 1/12 of this, then this must be 1/12 of that. What? Pi over 6. Let's do this next one an easier way. Are you ready?
Yeah.
Here we go. 45 is what fraction of 90? Half. So this has to be half of pi over 2. Pi over 4. Ready?
Yeah.
60 is how many 30s? 2. So this has to be 2 pi over 6s. What's 2 pi over 6 though? Pi over 3. So from now on, most likely, if I'm talking about a 30-degree angle, I'm not going to say that. I'll say pi over 6. 45 is a pi over 4. 60 is a pi over 3. If I'm talking about 90 degrees, you're going to say pi over 2. You're going to hear me use the radians on these angles from now on. Okay? So let's keep moving through this. I bet we can do this. There's probably a pattern of some type on this. So here we go. Pi over 3, pi over 2. What's this going to be? How many 60s?
2.
How many pi over 3s? 2. So it's 2 pi's over, oh my goodness.
Wait, where did that come from?
Because 120 is how many 60s?
2.
So I need 2 of these. 2 pi over 3.
Oh.
Or 120 is how many 30s? 4. I need 4 pi over 6, which is 2 pi over 3. Just thinking it through, right? All right, what about 135? How many 45s is that going to be? 3. So it's what? 3 pi over 4. How many 30s are there in 150? 5. So how many pi over 6s do I need? 5. So it's what? 5 pi over. Okay? Pi. What's this one going to be? Want to do something cool? Watch this. Did you notice how this is a straight line?
Yeah.
So I have to just take pi over 6 and add what to it? Pi. 7 pi over 6. Oh my goodness, Snyder. Here we go. This is going to be what? You're taking pi over 4 and adding pi. What'd you say? 5? Did you say that?
I said 8 over 6. I
Well,
don't know.
the denominator won't be 6. Every time you're at a 45, the denominator is always going to be 4. Okay? And this is at 5 pi over 4. Because I'm going to just real quick. From here to there is pi. Which is what? 4 pi over 4. What's 4 pi plus this 1 pi? Does that make sense to you what I'm saying?
Yeah.
Here's 1 pi. I started at pi over 4. I add 4 pi over 4. I end up at 5 pi over 4. Yes, no? You don't understand what I'm doing there? Okay. Start here. Where am I at right now, Maddie?
45.
What in radians, though?
5 4.
And I'm going to travel all the way to this one. This is a straight line. See it? It's a straight line. If it's a straight line, this is 180 degrees, or how many radians?
1.
Pi radians. Right? 180 is pi radians. This is pi radians, which is the same as 4 pi over 4. Why did I do that? Because I have to have a common denominator. So what's 4 pi plus 1 pi?
5.
That's why I have 5 pi over 4. That's the way I just did it. There's a lot of ways of doing it. I mean, there's a lot of ways to think through this. 240. Here we go. Where am I at? What's this one going to be?
4 pi over 3.
4 pi over 3. Okay? If you want, you could say, hey, 240 is how many 30s or how many 60s? There's a lot of ways of going through this. I like it, though. I like this idea of adding pi radians. I'm trying to stay out of the degree mode as much as possible. I want to stay in radian thoughts. 4 pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. 11 pi over 6. Okay. Now, You need to know those. Like this. If I say 11 pi over 6, you got to know exactly where that is in this circle. If I say 4 pi over 3, you got to know where it is. You have to memorize those. They have to become something very easy for you to see in your head. Okay? You have to know where they are. Okay. Now, what is left to fill in here is nothing more than ordered pairs. Bunch of them. And there's ordered pairs at the location where the radius comes out and hits the circle. Nice enough. Now, 4 of these ordered pairs you could give me right now without me telling you anything else at all. Guaranteed. 4 of them you could give me. Can anybody give me one for sure they know? What? The first one? This one right here? It's over 1 what? Yeah, and why is it over 1? Because I said it's a radius of 1. It's a unit circle. So I know for sure that this location right here is at 1, 0. What other 3 should I automatically know? Come on now. Pi over 2 at the top. What should this be at? Careful. Look. What? 0, 1. Thank you. Look. Remember, this is the origin. So here I go over 1. I don't go up or down. That's why it's at 1, 0. Here, I don't go left or right. So it's 0, and I go up 1. Every one of these is a length of 1. That's all I'm doing. So what's this going to be at? Well, I'm going to go over 1 to the left, which makes it negative 1, but I don't go up or down, so it's 0. Is everybody okay with it now?
Yeah.
Good. Okay, and the bottom one down here at 3 pi over 2 is 0, negative 1. Those should be like, boop, done, got them. Okay? All right, here we go. Now, I'm going to help you find one of these. And then you're going to be responsible for finding the rest of them for homework. Okay? And then, not only are you going to be responsible for finding them, you should be able to explain to me how you know what they are. Because I could find them on the line, that's no problem. So, here we go. I'm going to show you how to actually get the coordinates at pi over 6. I'm going to show you that one. Oh, let's go with the creative pen. Let's go with this one. All right, here we go. What I'm going to do is I'm going to draw a triangle. Beautiful triangle. Isn't that beautiful triangle? Now, on that triangle, guess what I know? Now, I'm going to do this only this one time for you in degrees to help you understand it. This has to be how many degrees? 30 degrees, because the central angle measurement is the same as this arc. I know this is the unit circle, so it has a radius of 1. And this has to be a right angle. This is the short leg, and this is the long leg on a special right triangle, which is why I did that with you before spring break, and we talked about it again yesterday. So to find these coordinates right here, I'm going to use the special rules for 30, 60, 90s. All right, let's do it. Here we go. I've given you the hypotenuse. How do you go from hypotenuse to the short leg? Divide by 2. So if this is 1, what does this have to be? 1/2. Boom. This is 1/2. The y value is 1/2. Does everybody see how I just did that? And I used special right triangles. Okay, great. Once you know the short leg, how do you get the long leg? Multiplied by? This is why I told you guys to know your special rules. Multiply by radical 3. So this long leg is going to be 1/2 times radical 3, which is radical 3 over 2. why those are the coordinates they are. I've done it by using special right triangles. Okay? Now, your job tonight is to fill in the rest of these ordered pairs. You only have to use special right triangles one more time. And that's it. And then once you've done that, you can use your brain and the knowledge of signs in the quadrants of what's going to happen. Think about what's going to happen to these. I want you to look at this. What do you notice about the x values here? They're opposites. And the y values are the... What do you think is going to be true about this and this? The y values are going to be the... And the x values are going to be... So I don't need to keep doing this over and over again. These are all reflections of each other across the x and y axis. And if they're reflections across the x and y axis, all you have to do is change the signs of either the x coordinate or the y coordinate. So you only have to use special right triangles to find this one right here. And once you've done that, you don't have to do any more special right triangles to find the remaining coordinates. Okay, so when you come back on Thursday, I'm going to ask to see this on your desk filled out. Right? And then we're going to make sure you have them correct. Okay? And you should understand. If somebody said to you, well, how did you know that? You could show them why. You have to just be able to explain to me why you know something is true. Okay? The most important thing is why. Because nowadays it's so easy to get the answers online, but understanding why it's the answer is a whole different ballgame. And saying Google told me it was is not a good answer. Or, you know, Wolfram Alpha, what is it? Wolfram, all those things. Okay? So tomorrow, by the way, there might be a small assignment, not on so much the unit circle, but more on the idea of do you understand what radians are? The degrees, radians. I might ask you to do that, but there won't be anything where you have to go ahead and fill out the unit circle. But I can tell you right now on Friday, you will have a timed quiz where you have to fill out the unit circle in radians and all the coordinates, and you only get like 4 minutes to do it. But that's not a problem if you know it. Okay? All right. So again, if you're walking down the hallway and Mr. Mitter or Mr. Gwendon stops you and says, oh, you just learned about radians? Explain to me what a radian measure is. How do you find radian measures of an angle? And then what is 1 radian, and how many are into a full revolution or a half revolution? You'd better be able to answer them. Yes. If they say how many radians in a full revolution, you're going to say what? You know.
No. This is aggravating.
It's not aggravating. It's new. That's why it seems aggravating.
I couldn't even get the fractions. So how am I supposed to get them?
You got pi over 6. You were the one that gave me pi over 6, didn't you?
No.
Yes, you did. Yes, you did. You gave me pi over 6 because I said
Yeah,
what fraction of 30 is 60?
Well, that was easy. Then you got.
1/12, and then you what?
And then after we got past that, I just did not know after like the second, third, and fourth quadrant.
You're gonna be fine. Don't freak out now. It's the first day dealing with it. Okay? The first day dealing with it.
Why I tried out like the 4 points before you were talking, did the special right triangle to the 36. I was already filling out the the 45, the 135, the 225, and the 315 because I was like, x is the same on both of those, and the hypotenuse is just 2x. So I was like,
Good. Yeah. Yeah. You guys are all able, if you can do the special right triangles and you understand how to reflect things across the axes, you can do this, what I've asked you to do. I know you can. Cool. I have faith in you.
I'm still
But here's the whole
By the way, Abby, remember earlier when you said no and everyone else said yes, they were the same rotation?
It's not,
Remember at the very beginning of class when I rotated my body both directions, I said it wasn't the same and you said no?
Yeah.
You were the one that was right because one was positive and one was negative.
I said no, but I didn't say
See? You were right. Remember at the beginning of class? Remember when you said no? You were correct.
Yeah, after being
Because it's direction matters when you're rotating. Direction matters.
do the wrong rotation.
Guys, have a great day today. Go outside tomorrow and get some fresh air. Do your work outside.
I don't know what happened to my notes on those special triangle rules or something, because I don't have them.
What? They were in your pencil box.
Maybe, who knows?
Oh, I'm so sorry you lost that yesterday. Oh, Abby, Bo, Babby, Banana, Fan, Pope, Abby, me, my, Mo, Mabby, Abby.
What can I do to get out of this class?
Nothing.
What do you mean nothing?
No. Do not take one day and make a judgment from it. You need to relax. You need to just give it time, Abby.
Yeah, I don't remember.
Time. Okay? You trust me? You need, Abby,
Yes.
trust me. Okay? You're gonna be fine. You're not. You don't need to worry. You really don't. You don't need to worry.
There's the
You're
45,
gonna get through.
90, 45 thing. And then the one
I
that
don't
we just did
understand
on
a single thing that just happened.
which
You
is
don't
the
even understand the degrees I put up. You don't understand why it's 90 degrees at the top? No?
Inverse.
Okay.
30.
You're still gonna be fine. Because I'm gonna make it.
And then if you want to find the next one, then
And then.
if that's
Good
45.
luck.
Abby, I have faith in you.
The other angle.
I do. So one of us
Alright.
is key to having faith, and that is you. I
See you,
believe
Mr. Snyder.
all you need to do is give me your best effort and you'll be fine. That's all I ask. Can you give me your best effort? And guess what? You're gonna be fine. Okay? Thanks, you too, Abby.
Sure, you visit me after. I know. I wanted to go to the bathroom to come say hi to you guys, but you guys left as soon as I got out of the kitchen. I'm like, okay. It's a very strange name for a company. I got it. Is this a no to thing? All the time. I'm talking about like in the series. This is a no. Yeah. Yeah, it's fine. Well, every skater, they tell me, yeah, you're not supposed to. Well, every skater, probably a 2-year-old on the tracks for where else? You can come see me again on Wednesday. Tomorrow or Friday. What's the point of this? I know, but I'm able to see them. It's nice to see a friendly face.
Why do I always feel like I'm sick? I always feel like I'm sick. I keep going to this desk. Not where I sit.
Just wait till I get the car. Or you will never see the director. Always go inside. No, you can see me. I'm like in that little kitchen. Look at that one person.
Last time we used the restroom.
Hurry up, goon.
Oh, no, right. I know. That's the funny part. middle school thing, bro. He was so fun. But then his content just got old. Because all he did was steal. Ew. Shut up, bro. He visited me at work yesterday. Here's what you were, but we never did. No, I'm talking about like earlier, like when I first got it. First got the W. Someone at my job said it. What? Because it's a 47 days old. You said you were going to come by because I said I told your schedule, and you were like, I'll come by and visit you Wednesday next week. And you never did. I guess that.
You get like fired.
Oh no, she just called off like 40 some times, so she's invited to some girl at work. Act like you've been there for a while. I haven't been super easy to do. I have a water on 6. No, I don't. You turn 18, you're a legal adult, so you can just take the driver's. You don't need temps. You don't have to take swim, but you have to take temps for 6 months. I have someone at work and they had temps for 6 months. So I can just get the temps free. Yeah, we'll pay for it, but you don't have to take